Hello everybody, my name is Halo. Welcome to this video series where we are solving Codeforces problems in Python. We are doing the Codeforces A to OJ ladder, and in this video we're going to be looking at problem 266A, which is called stones on the table. It's quite a simple problem. Let's just go ahead with the video and see how to solve it. So this is the question. There are n stones on the table in a row. Okay, each of them can either be red represented by R, green represented by G, and blue represented by B. Okay, so we have to count the minimum number of stones to take from this table so that any two neighboring stones have different colors. For example, let's just have a case where it's R or G. If you remove this R alone, we can see that the stones will now become RG, that is neighboring stones don't have the same color. Okay, so our task is to find out what is the minimum number of stones that we can take in order to achieve this. Okay, so this in this particular case will be 1. How do we solve this for a case where there can be up to 50 stones of R, G and B? So that is the question that we're given with, and let's take an example. So I think this particular input set is actually quite interesting and enough to kind of solve this problem. Let's take this case first. So we have R, R, G. Okay, and in this particular case we need to remove this particular R, and then that will give us R and G, and this will be 1. Okay, so answer will be 1, right? So what we are doing is essentially we're going through this element, we are then checking the next element, and we are comparing if this value and this previous value is the same. If it is the same, we want to remove this particular stone. Okay, and then we again do the same from here. From here we are saying, okay, this and this are different values, so we are going to not do anything, and the answer is 1. Okay, so let's take case number 2. This is also a very interesting case. We have R. Let me just erase this so that I can explain this particular case a little bit better. We have all R's. Okay, so we have 1, 2, 3, 4 and 5 R's. Okay, so now let's take this part first. So we know the answer is 4 here, right? Because all of this is there together. How do we arrive at that 4 in a kind of logical way so that we can generalize the solution? So first of all, we go through this element, and then we go to the next element, and we check, yes, the element before it is the same element, which means I have to now remove this particular R. Okay, so the count is now 1. Okay, now this R is removed. Okay, but now if you see again, I have to compare this with its previous element, right? So again I have to add 1, and then I have to remove this R also. But then again I have to compare this with the previous R, where there are 2 R's that we have deleted now. Okay, so again we have to add 1, and then again same thing. Once this gets removed, we have to now compare with this R, which is like 3 spots. So we have deleted 3 spots, so this will be 4, and finally get an answer. See, this method right here, while it works, I don't think it is the easiest way to understand this problem. Okay, so let's look at something. Let's break this down into a much easier problem that we can code. Okay, so let's just take this case again, 1, 2, 3, 4 and 5. One thing to keep in mind is, let's say this and this is R. Okay, and here we are obviously seeing this. Here also we are going to be seeing the before element. If we remove this part right here, we are going to be looking at this, which is also R only. So if you keep in mind, this emptiness is being created. Why? Because this element is the same as this element, correct? Right? So, and if the next element is also the same element, we are comparing with this because we are removing this element. But if you think of it, you don't even need to remove this element in the first place. Instead of checking this R after removing this, what we can do is we can directly check this R. Why? Because this R simply means that this element and the element before is the same thing. So what I'm trying to say is, instead of checking if instead of removing this second element, right, because elements 1 and 0 are the same, and then comparing 2 and 0, we can compare 1 and 2, because if 1, 0 and 2 are the same, that means, let me just name this better, 0, 1 and 2. Okay, that means elements 1 and 2 are also the same, because elements 0 and 1 are the same. This is the transitivity property, right? So that means that we don't even need to remove anything. All we need to do is, just for any element, so any combination B, just check the element before it. If it is the same, then add 1 to the number of stones to remove. Just keep repeating that until you get an answer, and then go ahead and print this answer, right? I hope that you are able to understand why we got through this, why we are not removing anything, and that's the transitivity property that we're using here. And if you are able to understand this, I highly recommend to go and code this yourself. If you aren't able to understand this, just bear with me. Let's go to the code now. The code is actually very, very simple. Let's see how that works. Right, so as they're saying, we have to first get an input n, then followed by a string. So let's just start with that. Let's take an input n, and then let's just take a string. One thing when you're working with Python, especially in Codeforces, is this input n is something that is not really needed, because Python dynamically determines the size of the string. But if you're using something like C++, you probably need to do a for loop just to get this particular string input. That is why this n is that. For Python, it is of no significance. You don't need to pay it any mind. Okay. So now let us go ahead and say something stones to remove. Okay, stones, and then let's call that 0. And this will be the minimum number of stones to remove. Okay. So since this is a list, this is a string, we can definitely go ahead and iterate through a string. So what we'll do for, and we obviously need indexes. So we'll do for I in range 1 to len of string. Why we are doing this? If we go back here, we're going to one element and then checking the previous element. So in the first case, if we start with 0, that means there's no previous element to go back to, which will throw an error. That's why we're going for 1 and then checking the previous element. Okay. So you can also go with 0 and check the first element. This is what I'm doing. If you guys have a different logic, please let me know down in the comments as well. Right. So what we're checking here, if this particular entity, this particular element is equal to the element before it, that means what you do, you just increase this stones count by 1. Okay. And then once you're doing that, just print stones, and that should be working. Let me just run it. Yeah, that's it. That's the code, right? Literally, it's 5 lines. But I hope you're understanding why we chose this, and that's why it's very, this code is very small. Let me just go ahead and submit the solution so that you understand that this works. Right, I think it'll take a while for it to get submitted. I'll get back to you once that is there. Right, so as you can see, the solution is accepted. That is it, guys, for this video. I hope this code helped. I hope my explanation, you could understand some of it. I'm trying to get better at explaining stuff. If you guys have any questions or any alternative approaches, please let them know in the comments so that other people can look at it and they can answer it. I will try my best to answer it. And yeah, that's it. I'll see you in another video. I hope this helped. If this helped, hit the like button. Yeah, I'll see you again. Bye.